Welcome. So in this video we'll learn about how to detect vegetable oil in ghee using RP-HPLC, which is reverse phase high performance liquid chromatography. Okay, so here in this video we'll learn about how to detect vegetable oil adulteration in ghee using reverse phase high performance liquid chromatography. Recently FSA has given this method to detect adulteration of vegetable oil in ghee. Now this principle is based on the fact that in animal fat, or in ghee we are having cholesterol as the major sterol, and whereas in vegetable oils beta cytosterol is the major sterol which is present. So RP-HPLC method is based on the detection of cholesterol and beta cytosterol as markers in the US. So beta cytosterol is a marker for the vegetable oil, whereas cholesterol is a marker for the animal fat, or is present in major sterol in the milk fat or ghee. Now, just to define unspecified matter, so unspecified matter is that matter or those substances which are soluble in oil or fat, but after sonification are insoluble in water but soluble in the solvent used for their determination. Used for its determination. So in simple terms, unspecified matter is that matter which is not sonifiable. Sonification means that we know that when triglyceride or fat is treated with alkali, then will have corresponding soap formation will be there. So if we are making use of sodium hydroxide, then we will have sodium salts of long chain fatty acid, and if we are making use of potassium hydroxide, then we will have potassium salts of the long chain fatty acid, which are nothing but the soap. Now the soap form is soluble in water, but the unsoluble matter which is not soluble in water, but it's soluble in the solvent which is used for its determination. And then what does USM includes? So USM includes the lipids of natural origin. They are actually the lipids of natural origins. These are not sonifiable, as already told. When examples are sterols, higher aliphatic alcohols, pigments, vitamins like A, D, E, K, and then hydrocarbons. All these materials, as well as some foreign matter which do not form alkali, we do not form soaps with alkali, and are non-volatile at 100 degrees Celsius. These are non-volatile at 100 degrees Celsius. So these are these definitions. What does USM include? It includes sterols, higher aliphatic alcohols, pigments, vitamins, hydrocarbons, as well as some foreign organic matter which do not form soaps with alkali and are non-volatile at 100 degrees Celsius. They are non-volatile at 100 degrees Celsius. Now, as milk fat or ghee contains 0.2 to 0.44% USM, ghee contain 0.2 to 0.44% USM, and if you see that principal sterol of milk fat is sterol, as already told, that principal sterol in ghee is sterol in cholesterol, and cholesterol content of milk ranges from 0.2 to 0.4% by weight of fat. So cholesterol forms 0.25 to 0.4% by weight of the fat. Now, as already told, the beta cytosterol is a plant sterol, which is the indicator for the adulteration in ghee. In ghee, as we know, there is no presence of beta cytosterol. If the peak in the HPLC chromatogram is appearing, then we will say that vegetable oil is present. Now, this method is applicable for the detection of vegetable oils, coconut oil, sunflower oil, groundnut oil, some designer vegetable oils in ghee. Now, vegetable oil sterols correctly are known as plant sterols or phytosterols. उनको हम plant sterols कहते हैं या phytosterols कहते हैं. Now, sterols vary with the origin of fat and are affected by food processing. Sterol की concentration डिपेंड करती है कि फैट का क्या ओरिजिन है, और फूड प्रोसेसिंग, जब हम प्रोसेसिंग करते हैं तब भी स्टेरोल की कंपोजिशन इफेक्ट होती है. Now, sterols are affected by the food processing also. Now, we see that, as already told, cholesterol is the major animal sterol, and in plant we have seen beta cytosterol, camptosterol, stigmasterol, brassicyosterol, vanasterol, stigmastenol are also major plant sterols which are present in vegetable oils at much higher concentration than cholesterol is in animal fats. So we see some of the sterols which are shown on the slide, that beta cytosterol, camptosterol, stigmasterol, brassicyosterol, aficionado, stigmastenol are the major plant sterols present in vegetable oils at much higher levels than the cholesterol is in the animal fats. Now, if we see the major sterols which are present in vegetable oil, as written on the slide, we can see that major is the cytosterol, camptosterol, stigmasterol, brassicyosterol, aficionado, and then cytostanol, and then camptostanol. So all these are the sterols which are present in vegetable oils, and we can see here the major sterols which is present in the vegetable oil is the cytosterol only. Similarly, we see some of the sterols which are found to be or reported in the milk fat are the cholesterol is there, lathosterol, camptosterol, lanosterol. So all these are the sterols which are present in animal fat, and the major sterol of the milk fat is the cholesterol, that is 95.5% of the total sterol. 95.5% of the total sterol is nothing but the cholesterol. Now, if it's written that this is the marker, the beta sterol is altogether absent in milk fat, and which form the basis of this method. So, in the chromatogram, if you're having the peak of beta sterol in the in the USM of the ghee that has been extracted from the ghee, if we are getting the beta sterol peak, then obviously it has come from the vegetable oil, and we will say that our sample is adulterated with the vegetable oil. Now, how to prepare USM, how to extract the USM from the milk fat, that the method is given. So first you take 1 gram of fat in a screw capped test tube, preferably glass test tube you take, and you weigh 1 gram of the fat in a screwed capped test tube, in a glass test tube, and then you add 25 ml of 5% methanolic KOH, which is used for sonification. 5% methanolic KOH can be easily prepared. You take 5 gram and then dissolve in some quantity of water and make up the volume with methanol. You will have 5% methanolic KOH, and this is used for the sonification reaction. Then you keep the tubes in water bath, maintain an 90 degrees Celsius for 50 minutes with vigorous shaking at the regular intervals, so that the sonification reaction to be completed. Now, after that, you take out the tubes from the water bath and add 5 ml of water and 15 ml of hexane. You add 5 ml of water and 50 ml of hexane. Vortex for 1 minute. Centrifuge at 1700 times G, or which is around 3000 RPM for 5 minutes. You have to centrifuge at 3000 RPM for 5 minutes, and then you put out the upper hexane layer completely. Take the upper hexane layer completely and dry to obtain USM. You dry it to obtain the unsonifiable matter. So you first you can dry it, preferably you dry it in micro concentrator, and then you will have the USM. So the USM which is obtained, you dissolve it in 300 microliter of chloroform and add 500 microliter of methanol. You vortex it and mix it and filter the above content or above extract with 0.22 micron nylon filter. Okay, so that no impurities are entering into the column of HPLC. Now, whatever the filtrate which has been obtained, that you run through you perform the HPLC analysis on the same. So HPLC conditions which are to be used are given below. That you take we have to solvent which is to be used is acetonitrile isopropanol in 9:1 ratio, that is to be filtered and degassed. Okay, so you mobile phase which you take is the ratio of acetonitrile or isopropanol in the ratio of 9:1. You filter it and degas it. So the conditions are shown here. So you have to use CD18 column for 4.6 by 250 mm dimensions, and 5 micrometer is the pore size, and then column oven temperature to be kept at 30 degrees Celsius, flow rate 1.5 ml per minute, and then wavelength you will use 105 nanometer as PDA wavelength. 20 microliter is to be injected, and then runtime is 30 minutes. The chromatogram will appear, and then the solvent I already told that the ratio of acetonitrile and isopropanol mixture, that is in the 9:1 ratio. Now, if you see the retention time of which will appear in the chromatogram of 35 minutes, it will having the cholesterol peak retention time 22.8, and stigma sterol 25.5, and beta sterol at 29.05 minutes. The peaks will be appearing at these retention time under prescribed condition of the method. Okay, now so I told we have seen the retention time now for different standards like cholesterol, stigma sterol, beta sterol will appear, and the column conditions we also have seen. Now, how will we identify the peak? So we have to run the standards, so that we will be able to know the retention time, and we have to match whatever peaks we are obtaining in our sample with that of the standards. So to identify the peaks, we have to make use of the standards. So we have to compare the retention time with those of the reference standards we are using. Now, limit of detection vary with the type of volatility. So the LOD has been reported for different types of oil. For example, the method is capable of detecting coconut oil at 5%, refined soybean oil at 1%, groundnut oil 2%, sunflower oil at 1%. Now, detection and reporting of any result below 1% should be done cautiously, because detection limit is never been less than 1% for any type of oil. So if less than 1% is, and you are detecting any peak, then that is to be reported cautiously. So here is the chromatogram. You can see that the first chromatogram is of the standards. This is cholesterol peak, and then we have cholesterol, stigmasterol, and this is beta cytosterol. Beta cytosterol returns any 22.780, whereas cholesterol and stigmasterol is 19.993, and then you have cholesterol is 17.697. Now this is the sample of our sample. So any sample you can take. So you have injected USM of pure cow ghee, and then the chromatogram is given here, and we can clearly see that the cholesterol peak we are having, that is returns time is 17.687. this is near to 17.697. so this is cholesterol peak, whereas no beta cytosterol peak is present in this case. So this is indicating that our sample is free from vegetable oil. So what will be our inference? That pure or genuine ghee sample, the peak of beta cytosterol might be absent, and detection of beta cytosterol denotes the adulteration of ghee with the vegetable point. So if in our sample beta cytosterol is coming, which is not at all present in ghee, this will clearly indicate that our sample is adulterated with vegetable oil. So this is how we can detect the presence of vegetable oil in ghee using RP-HPLC. Thank you.